Struggling through life. Is the activity on Wednesday a group activity? It's the same template as last week, so Wednesdays is individual and Fridays is group, except they're not the same activity this time. But you have till 6 a.m. Like, I don't understand why ending at 3 p.m. is an issue. You have till 6 a.m. the following day. There's plenty of time. You can watch the VOD, and even when the Mike doesn't post the videos on YouTube, when I tell him not to post on YouTube, they still show up as VODs on Twitch, so you can still watch. You don't have to miss anything. I'm super generous in that by giving you so much time to do an activity that should technically be done at 3:50. It means something is wrong with your code. Thank you, QT Bunny. Alright, that should be enough for my continuous deployment to update. There we go. Oh, I did get a haircut, Syncoriz. My hair was getting pretty long, too. It was bad. I got out of sync. I got off schedule with my haircuts and just wasn't getting back on schedule. Finally, my wife's like, Jess, you need a haircut. We're doing it today. And that day was yesterday. I can't complain. I like it better. It was getting way too long. Oh, I see what you mean, struggling through life. You wanted it to be individual. I read it the opposite way, that you wanted it to be a group activity so that you didn't have to do it and your group could do it for you. Sorry about that. I read it backwards. I read it the wrong way. Beefy Indian Kid, what's up? All right, let's talk about some metrics. 5 minutes in, so let's do this thing. Oh, I don't know why, but today's draining my energy. Been constantly doing stuff since I woke up. I love metrics. Good, Apple Adam. You should like this lecture. This lecture, I will say up front, this lecture is kind of abstract, that we don't talk too much about specific metrics, but talking about the idea of metrics in general and how they're used. So let's do it. Let's put the E in software engineering, the E in SE. So most of what we've done so far in the class is focusing on the software and the organization around software, but not so much the engineering concepts. So things we have talked about: team dynamics. We talked about it a bit, but even beyond what we've talked about, just experiencing the dynamics of your team. I'm sure you're learning a ton about team dynamics. This is one of the first times, at least first required times in our curriculum, where you have to really work in a team closely. Some other classes have some teamwork or work in pairs, but this is probably the biggest experience in a required class at the very least, where you're working on with a team to produce software. So you're finding out much for the first time how teams, behave together, and it's probably not as pretty as you'd hoped it would be, if I were to guess. Some teams are working really smooth. I'd say most teams are getting along at best, and some teams are kind of crashing and burning. But you're all learning something about team dynamics. Yeah, most of CS is abstract. This is, and some of our courses are like abstractions on top of abstractions on top of abstractions. We very rarely talk about just concrete stuff. So I guess you should be used to that. You're distracted by my new look. Apple Adam, yeah. So you're learning a lot about group dynamics. You're learning about what happens when group dynamics go wrong, at least. We've talked a lot about management. Of course, you have your project manager. You're understanding how somebody's going to manage your projects, I guess. And a lot of that's going to be, when you get out there in the working world, you're going to have a manager like that who is calling the shots and really running the project. And then you're going to be one of the workers on that project, at least when you're entry level. So understanding how that works and being able to see what your manager is doing, what kind of decisions they have to make. One of the best things, the best advice I've had, I follow this quite often, is when your management or someone above you in the power structure of your organization makes a decision, especially if it's a decision you don't like, put yourself in their shoes and try to figure out where they're coming from. And almost all the time, I find it very, very rare that I find they're actually acting in bad faith. They're just, in almost every case, especially when it's a decision I'm unhappy about, they're acting according to their incentive structures. Whatever they're incentivized by, that's what they're doing. For, yeah, I'll go there. For example, like the dean's office. No matter who's the dean, one of their main jobs is to balance budgets. So a lot of their decisions are made based on budgetary matters, not what's best for the department, what's best for the professors, or what's best for the students. It's how are we going to get money? How are we going to balance this budget? How are we going to get the money to balance it? How are we going to cut spending to get these numbers to be in the black instead of in the red? So it's easy to say that, it's easy to disagree with the dean's decisions, but once you look at what they're faced with, and that if they're hemorrhaging money, the provost is going to be upset with them, and then in our case, SUNY is going to be mad at them, and that money has to come from somewhere, and they're probably going to lose their job if they don't balance that budget. Well, then I started understanding, like, well, that's just the problem that they're faced with. They didn't cut my budget because they hate me. They want to keep their job because they make a ton of money. So anyway, that bit of a tangent, but with your project managers, even this semester, when they make a decision, try to put yourself in their shoes and try to understand why they made that decision. It's usually very helpful. But anyway, we talked about management and managing a project, organizing that with the Scrum boards so your manager can know what's going on. Some of you are not doing that very well, especially for some of the individual grade adjustments that I've made recently. If you did a lot of work on a project, but I can't see that work, it's not reflected in all the project management, you effectively didn't do anything. So some of you got caught up on that, but it's a huge part of the course is managing your project. This course, I've said it before, but this course isn't about producing code. I know you can produce code because you got here. You made it to 442. Congratulations. Now we're talking about how to engineer software. Anyway, I spent too much time on that bullet point. Software life cycles, we started off with waterfall and eventually talked about agile and scrum, which we use for the project using sprints. This idea of sprints comes from that. Requirements, user stories, gathering requirements from your customers, and in negotiating with your team what stories should be captured, what requirements should be captured in stories, talking with your PM to figure out what stories should be pursued for each sprint. Designing your software, we talked about concepts like, oh my goodness, I always forget the two C's, coupling and cohesion, and how to design your code for testing to be able to be tested. And by the way, I just went through those 4 activities that we did about design, and most of you did just fine. A kind of spooky number of you really missed the point or just didn't try. So hopefully you got the ideas of design and you're using those ideas in your code, in your project, because designing your software well can save you so much time and so much frustration. I know I've had plenty of projects where I've had poorly designed and poorly architected, is that a word? Code, and it will catch up to you. It will catch up to you eventually. I've gotten to the point where I'm like, no, I can just make this work. I'll just add one more hack over here and one more hack over here and one more hack like this. And it gets to the point where you just can no longer build this large piece of software on top of a really crappy foundation. And usually when I get to that point, I start from scratch. I do a huge not from scratch completely, but I do a huge refactor and restructure my entire code base from the ground up. And then when I can reuse code, of course, I'll reuse it. But I'll rebuild that foundation from time to time. And sometimes you don't know where a project's going to lead to. So you don't know how to build that foundation because you don't know what you're going to build on top of it. But once you get to a certain point, it's worth going back and doing a refactor. That technical debt, exactly, Synchronous. That technical debt, it's always got to get paid. You got to pay it, or out there in the real world, you're going to go to another company and somebody else has to pay it. Somebody's got to pay that debt when you have terrible design. You miss one activity, how does that impact your grade? Like, to be honest, almost not at all. There's quite a few activities, and that's 10% of your grade. We're over 10 activities already, so each activity is less than 1% of your final grade. So if you're doing well on the project side of things, the project is the majority of your grade. If you're doing well on the project and you miss an activity or two, you can still get an A in the course. But if you're not in the A range, if you're doing not so well on your project, doing those activities can improve your grade a bit. The activities aren't meant to be punishing. They're meant to be, helping you learn. It's more than minus 0.5, but that depends on how many we end up having throughout the entire semester. I don't think there are 20 total planned, which there would have to be for a 0.5. Anyway, testing, of course, you're doing testing for every task that you write and every story that you write, whether it's acceptance testing for stories or more technical testing, sometimes through unit tests, sometimes through scripted testing, through your tasks. But testing, of course, and designing for testing was a big topic in at least one lecture. Which, again, for them activities, I feel like the point was missed with a lot of you, but it is what it is, I guess. Like when we did I'm just thinking of how to restructure those next time. The tennis design and the darts design, a lot of the class missed the point of, I want you to design your modules and methods in a way that's going to make them easier to test. A lot of the ones, a lot of the submissions were just, whatever, it's a lecture activity, I'm going to submit whatever and then be done with it. So a lot of those I didn't give full credit to, unfortunately. But anyway, I'm getting sidetracked again. That's what I'm thinking about, because I did that, over the past few days. Sunk hours of my life into that. And then implementation, you've been doing this for the past 3.5 years, so we haven't talked about this directly too much in this class. But this is inevitably something that you have to do for your projects. You have to actually work on your tasks, contribute code, push code to your repo and everything, actually implement the project. So let's talk about the other side of this, the engineering side, which is more following precise rules and following the numbers and really planning things out and figuring out which decisions to make based on these values. Like somebody designing a bridge is going to have to look at the numbers, like how many cubic feet of concrete am I going to need to make sure that this bridge is durable enough to withstand the traffic patterns that I expect to see. Engineers have to ask these types of questions and plan ahead for these kinds of decisions. If I'm designing an aircraft, how much lift am I going to need? How much surface area? How many square inches of surface area am I going to need on each flight surface to be able to generate the lift that I need, to generate the control over the aircraft that I need, etc. Some questions that if we're just writing software, we might not ask ourselves and we might not answer. We might just dive into some code, as we like to do. Nothing wrong with that. Just diving into code and hacking something together without the planning, without the planning ahead, without the reflection afterwards, after the fact, etc. So let's talk about this idea and the metrics involved for making certain decisions in a more engineering mindset. So we want to look at the data, see what the data is telling us, and then change what we do moving forward based on that data and the results that we extract from that data, instead of doing what we usually do, especially in software engineering. This seems more prevalent, is to just make decisions based on our intuition. I feel like this is going to work, so I'm going to do it. Instead, let's look at some metrics and make decisions based on the actual hard evidence and the facts that the data draws up. So, and just because our data is numeric does not always mean that it's useful. And just because it seems useful doesn't always mean it's useful. So if we have random numbers, okay, that's not a useful metric. We want numbers that actually have some underlying meaning and some important meaning, not just made up stuff. I don't belabor, and Dr. Hertz doesn't belabor the point in these slides, and I won't belabor the point too much here, but like lines of code is a terrible measure. Well, I'll mention it in a few slides, but like lines of code is a terrible measure of software engineer productivity. It's bad. Hopefully I don't have to talk about that too much. You should know that that's bad. If a competent developer can write some 5 lines of really beautifully elegant code that's very self-descriptive and self-commenting and gets the job done in a nice, clean, concise way, and another developer does the same functionality but uses 50 lines of code and it's just a jumbled mess of crap, you don't want to say that the second developer is produced more than the first developer, because they certainly produced less, even if it's more lines of code. So that's a metric that's numeric, that's really useless. Unless the number of lines of code is 0, that's useful, because they did nothing. But it's just using numbers of lines of code and comparing 100 to 500 is not very useful. So just because it's numeric doesn't mean it's useful. And your metric should reflect reality. This is a beautiful headline. It's very clear, concise. It gets to the point. It tells a good story and everything. There's just one problem with this headline, is that Truman actually won that election. So you need to have your numbers actually reflect what's happening in your projects and what's happening in the real world. So we need nice, data that represents what's happening, and data that's useful to represent what you're looking for, and data that's actually accurately reflecting what you're trying to look at. What about computational complexity in general? When you want less code, assuming that both pieces of code do the same thing? No. So computational, or maybe, wait, am I reading that right? You don't want less code in general based on computational complexity. I feel like you're mixing a few different things. So, for example, in 116, I go over, for those of you who hate my 116 mentions, I don't know, you can just phase out for a minute here, I guess, but you'll miss the point. In 116, I go through insertion sort, and my algorithm's less than 10 lines of code, and it's, of course, an O of n squared algorithm. Then I go over merge sort, which is, I want to say 30, maybe 40 lines of code. It has a helper method to do the merging. It uses recursion. It makes 2 recursive calls even. It's more complicated to explain, of course, but it's O of n log n. So just because there's fewer lines of code does not mean you have lower computational complexity. You can, in fact, it's often the case where more lines of code, if you want a more computationally efficient algorithm, it's usually going to be more lines of code. For those of you who took 116, you've all taken that, 331, you know this, you can see the trivial algorithm. Usually the trivial, like an n factorial algorithm, is going to be trivial. Just try all the things and take the one that's best. But to actually get an efficient algorithm for a complex question takes a lot more code, a lot more explaining. So fewer lines of code does not always mean lower computational complexity. Well, the data was wrong. Yeah, the problem was they called the election before the results were actually in, because I think they wanted to be the first to get out there. They wanted to make sure they had a paper ready for the next morning, and they printed it too early. But they printed it before the data was there. They were wrong. They incorrectly, they didn't say the right thing. That's not who won. Dewey didn't win. Yeah, pockets. And then there's some really elegant code, which is few lines of code and computationally efficient. And that's where the really really nice looking code comes in, assuming it's readable. I would guess that. No, I don't know about it. Yeah, speaking of elections, go vote. Election day. I can't believe it's election day's tomorrow already. That for a while it seemed like it would never come, and then all of a sudden it's like right here. Excuse me. Election day tomorrow. It's a big one. In statistics lie. There's a good quote for this. I think it's statistics never lie, but people do. People will use statistics lie, except it's a lot cleaner quote than that. Who you voting for? Like, I'm going to answer that. So making sure that you're using the metrics right, because it's easy to, everyone vote Kanye. Is he even on the ballot? We'd have to write him in, I guess. So if you use metrics poorly, if you lie through metrics, or not even lying, implies that intent. But if you're using metrics improperly, this can be a lot worse than just not using metrics at all. You can get the metrics, like especially if you are being deceptive. Somebody can be deceptive and use the metrics and the data to show their point that they're trying to make. So, for example, if a manager wants to get a certain employee fired and they want a convincing case to go to the CEO with, they can find some metric. If somebody were acting maliciously, a manager were acting maliciously like this, they could find some metrics in some way to put shade on that person and make them look terrible. You can almost always find some way to do that. And yeah, I'll vote for myself tomorrow. That's probably the best option. Using metrics poorly can be so much worse. It can make you do, especially if you have metrics that it's like, oh wow, I never expected that to come out of the data, and then you act on that. It's an easy trap to fall into. We do metrics on failure rates in our courses. We'll run some metrics and try to extract some meaning from the data. If we're not very careful when we do that, we can end up coming to the wrong conclusion and making decisions that we shouldn't be making. And if you don't remember anything else in this lecture, hopefully you already are aware of this. This comes up in so many cases, all throughout life, not just computer science, of course. Correlation is not the same as causation. Correlation does not imply causation. So when we're running metrics for our class, one of the things we like to look at is if we have a certain thing that we do in the class, like a review session, or if I have an optional lab, maybe something that we would like students to be taking advantage of, or office hours, going to office hours, something that we'd like students to be taking advantage of, and because we think it will help them. One of the easiest things to do is, let's run some metrics to prove it. Students who went to this review session did better overall in the course. Cool. We have some data to work with. Now let's go to the class and say, hey, students who went to review session did better in the class overall. Therefore, where the error comes in, you should go to review session. Now, maybe they should, maybe they shouldn't. I think they should, obviously. But anything that they can get more help with and more explanations. But we can't exactly make that causation argument just because there's correlation. Because in general, the students who went to review session care more, and they probably, I would be willing to bet, studied more outside of review session, and then also happen to go to review session and also happen to do well in the course. It's correlation, but we can't imply causation. We can't say if everybody goes to review, out of people who go into review session, 90% of them got A's in the course. Therefore, if everybody in the course goes to review session, 90% of the class will get A's. We can't make that kind of conclusion. So there's very careful arguments that need to be made, and never ever assume causation just because you see correlation. It's incredible how often this mistake is made just everywhere. Speaking of politics, in politics, this and this happened, therefore this caused that. No, it Yeah, maybe water does make you a serial killer. Anybody watching the video on YouTube is going to be confused with that line. But yeah, I'll read the thing for the YouTube audience. All murderers drink water, therefore water makes you a crazed serial killer. False. I'll say false on that. Drinking water right now. Speaking of, I need a hydration break. Yeah, there's all kinds of lies you can tell with statistics. So how about this one? People with larger shoe sizes are better spellers. Who believes this statement? Who drinks water when we have soda? So I used to drink more soda. I still drink a decent amount, but whenever I drink it, like right before a lecture, or sometimes even during a lecture like I used to, I just burp way too much, and no one wants to hear that. So I now have my personal rule, no soda before a lecture. On a lecture day, no soda until after, if at all. Yeah, so this is actually a true statement. People with larger shoe sizes are better spellers. We can extract all the data. If we get a nice sample size that accurately reflects the population, the whole human population, we will actually find this correlation that people with larger shoe sizes are better spellers. This is a fact. There's no disputing it. But we can't act on this fact. Like if we say, hey, you have a size 15, you must be a great speller. You know, once we start doing that, well, we're wrong. Because the reason this is true, which you guys got it in chat, y'all got it in chat, is adults are good at spelling overall, you know, in general. And they also wear grown-up shoes. They have adult shoe sizes. Children, not so good at spelling. They're still learning, and hey, they have kid sizes of shoes. So people with smaller shoes, it's not necessarily that they're worse spellers. It's probably just because they're kids. So if you take like all adult sizes, everybody size, you know, 10, adult 10 and higher, or anyone with an adult shoe size in general, you're not going to see this correlation anymore. You're not going to see a correlation between shoe size and better spellers. I mean, maybe you will. Maybe there actually is some crazy stat, something out there that's making people with bigger feet be able to spell better. I doubt it. But if you look at the whole population, that's including children, better spellers. The larger shoe size is going to be better spellers, just because that's a good indicator that that person's an adult. So correlation, no causation, but there is a common cause for both things. There's a common cause for both the larger shoe size and the better speller, and that's adult or child. And that's what we mean by correlation versus causation. Usually if there's a correlation between two things, there's some third cause that's causing both of those. Students who go to review sessions do better in class. Well, there's just some third cause, usually that student is, you know, cares about their education and they're willing to put in the time and the hours that it takes to be successful. So they both studied, did well in the course, and also took advantage of review session and went there and got that extra help to supplement their studying. It doesn't mean the review, personally, I think the review session does help them, but we have to be careful about the degree to which we say that helped them, because there's that third cause that is definitely helping. I would say review session is going to help them, just not to the degree that we will see in the data. We won't see that much of a correlation if we force the entire class to go to review session. Yeah, exactly. Ice cream sales always correlate with higher drowning rate. Yeah, because it's summer. People don't go swimming when it's too cold for ice cream. Yeah, exactly, Sinkers. So we got to be careful with the data. What's a good software engineering? I wonder if I can get a good one quick. I don't have one. I'm going to take too much time thinking about it. Wrote more code last year than any other employee. Well, great. But that's like saying my aircraft has more material on it than any other aircraft. Like, you don't want that bloat in your code. This is something I see a lot in student submissions. When you're still first learning out how to code, your methods tend to be huge and bulky monsters of code. And like, I'll write my solution for an assignment, and it'll be, sometimes 5 lines of, I think, pretty elegant code. And then I'll look through, and that's my intended solution. I usually make this mistake. I have that solution in mind. I'm like, oh, the solution's super simple. It's super easy. They'll get this question, especially when it's like a lecture question, 116. They'll get this no problem. It's not that big of a deal. And then I look at the submissions, and all the submissions are like 20 to 50 line beasts of code, big bulky things. I'm like, wait, what? That doesn't mean that that's better code than my solution. It usually means the opposite. That measuring by lines of code is just not a good measure. So thinking of this algorithm, this method, each one of these is supposed to count as a line of code. Just because they put their semicolon on the next line, are we going to count that as a new line of code? Is that what that is? Do we count all of this? Maybe we count characters of code, and we say that this counts as extra characters because they didn't, instead of writing 8 minus 4, instead of just writing 4 here, they write this monster. Do we give them more money for that? Do we give them preferential treatment when it comes to promotion decisions? I think not. I certainly hope not. Copying this array over, I think that's what this is doing. No, filtering out this array using this big old loop instead of a nice functional programming idea. Oh no, this is just counting the sum plus 4. Yeah, this is awful too, ain't it? Oh, I see. Yeah. I did my math wrong. That's why I'm so messed up. I promise I looked through this, but I didn't look through it closely enough to figure out what it's actually doing. Yeah, this is 8 minus 8 for 0. Starts at 0 and then counts everything that we're not ignoring based on this ignore parameter. There are easier ways to do this. We could do this in one line with some functional programming. Just do count equals, not equal ignore. Get this done real quick without all this bulk. So, should this person have preferential treatment and be treated as more productive than you if you write this in a very elegant, clean way? Not to mention just the time it takes me to parse through this and figure out what the hell they're even trying to do. It's terrible code. So how about this measure? How many bugs you fix? If you fix more bugs, we'll give you more money. Is this a good way of measuring software engineer productivity? The best way to measure code is whatever makes it look like I did the most work. Yeah, I mean, I see that fairly often in this class. Students will do some really weird things. I mean, I can't prove intent, but things that are really weird and also makes it look like they did more work than they actually did. That's part of what takes the individual grade adjustments so long to do. So I have to look through all that stuff. Are they just trying to, pull one over on me? Some students will push a whole bunch of garbage code just so the contribution graphs and GitHub look good. Some students will even upload libraries. I like to think that's usually a mistake. But I wouldn't be surprised if some students did that on purpose. Upload a library just so that it says like 350,000 lines of code contributed. So yeah, a lot of people like to make it look like they've done a lot of work without actually doing a lot of work. So of course this one's bad because we're just going to write more bugs. I'm just going to write more bugs and then fix them. I'm going to write easy bugs to fix too, because I know exactly how I did it wrong because, I wrote the bug. I'll try to keep it on software, but just one teaching example. Like, how should I be incentivized to teach better? We don't have any good answers for it, so there really is no concrete incentive program. But some of the options are just absolutely terrible. What if I'm rewarded for passing more students? What if I'm punished rather for my failure rates? Well, now I'm just going to pass everybody without forcing you to learn anything. What if I'm incentivized by student evals, by the course evals at the end of the semester? Probably the worst decision anyone could make by incentivizing me with that. But what if they did? Well, still I'm going to do the same thing. I'm just going to give everybody A's and take my bonuses, because if the course is an easy A, speaking of metrics, if a course is an easy A, the evals go up. Like, universally. Like, it always happens. I messed up the grading structure in 442 before, where, especially my first semester, I was a terrible teacher the first semester. Some of you might argue I'm still a terrible teacher. To that I say, get out of here. Shut up. But my first semester, I was, had no clue what I was doing. But I messed up the grading structure so bad, I had so many wide open loopholes that most of the class got an A without really trying, without really having to do work. But that's still my highest rated class ever that I did. I got like an average of, it was over 4.5, I believe, out of 5 on the evals. The students loved it. They just said how great I was and everything. And I delivered no value to you. Like, really, you should be pissed because you paid tuition for me to deliver educational value, which I did not deliver because I didn't know what I was doing. But the students were the happiest they've ever been. Now that I, force you to learn a bit more, my evals go down, and I need to keep them, it's weird to word it like this, but I need to keep them down, because once they get too high up, either I really know what I'm doing and I can deliver value and force students to work and learn things and also keep them happy. Unless I hit that really good sweet spot, probably just means my course was too easy and I didn't actually deliver any value. As much value as I should be anyway. So we can't be incentivized by that. And luckily, all the department, the dean's office, they all understand that, so they don't take too much stock into that. If the course evals are too low and there are a lot of specific complaints, obviously they're going to do, I might have a meeting or two about that and it might look bad for me. But if I get like 4.0s instead of 4.5s, that's going to be fine. Student, 10th side, that's a good one. Student engagement. The problem with that becomes, how do we measure that? How do we measure student engagement? If there's a consistent way to measure it, especially across courses, so how do you measure it consistently from 115 up to 442 in all these classes? That's tough to do. But yeah, that's like internally, like just looking at my own courses, that is one of the measures that I use. How engaged is my class with the material? And what can I do to fix that? It's a hard thing to fix too. We can do things like force attendance to force you to show up, but to actually get students engaged in the course and engaged with the material is very, very difficult. But that would be one of my measures of success. If I can get a whole class, most of the class, really engaged. I haven't been able to really do that yet, but if I can get there, I'd be knowing I'm doing something right. Yeah, it's multivariable reward. And I want to get away from teaching, but for software engineering too, how should you be rewarded for being like a more productive? How do we measure how to be a more productive software engineer? It's definitely a multivariable equation, and once it becomes too complex, it starts to outweigh its usefulness. So, by and large, I think most companies just go with nothing concrete anyway. It's a lot of subjective reviews, like, do you like, after a while, so let me put it this way, for each of your teammates, you could probably accurately tell me how productive they are. You could rate them all, you could fill out the peer evals pretty accurately, and you could tell me who's being productive and who's not. So we can go off of that. Like, it's very subjective, so there are problems with that. But that's one thing that can work. Instead of trying to come up with, lines of code multiplied by your what's it called, cyclomatic complexity divided by the amount of time you invest, like any really wild thing we come up with. It's not going to work, and it's going to be able to be gamed. And just one more teaching thing, the grading for this course is the same way. I tried to have some more concrete grading criteria, and I know students would love to have those. This is exactly how you're going to be graded. But we can never do that in a successful way. So now we have the rubric, which is, each line on that rubric, each box in the rubric can be interpreted in multiple different ways. And there has to be some amount of that subjectivity, because whenever we make it more concrete, students are just like, well, you said I had to have 5 commits, so I committed 5 times with just 1 character each, so I met that criteria, so you have to give me my points, and it just doesn't work. So we have to say, like, did you do enough work? We have to say loose things like that for a lot of these reasons. Any metrics, you're going to game the system. Kind of like the security lectures, where once it becomes a game, you're going to lose. Once the grading structure becomes a game, I'm going to lose. Some of you are going to win. Once the promotion structure for software engineers becomes a game, whoever can play the game the most is going to win. And it's just not necessarily, that's not how promotion decisions should be made, and raises decisions should be made. So we have this idea of cyclomatic complexity, which measures the complexity of at least one method or one module, one chunk of code. And here we have, and we're just going to measure the decisions that your code has to make. So conditionals, loops, how many of those decisions have to be made. This code, and then plus 1. This code has a complexity of 4. We have a conditional, we have a branch in the code, we have another branch in the code, and we have the merging, another branch in the code, a loop that can go back up to the top of the code. So here we have 2 conditionals and a loop, plus 1, that's going to give us a complexity of 4. And this gives us some insight in how well the code is written. If a higher complexity is generally a bad thing, you have more complex code, it's much easier to have bugs in that code because of how much has to be tested. You want to test every branch of that code, it's going to be a lot of tests, and, well, some developers just won't write those tests. If it's too hard to write the tests, they won't write them. Coincidentally, if it's too easy to write tests, some developers won't, because it's so obviously correct. Why would I have to write a test for that? It's a simple method. So it's hard to get developers to test them, but there's much more likely to be bugs in those modules. So as this complexity measure goes up, that's where the bugs are found, and that top 20% of complexity of modules, this follows the 2080 rule that shows up everywhere seemingly, has about 80% of the bugs. It's always in those big complex blobs of methods where we're going to find the bugs. So as a general rule, rewrite any method with a complexity of greater than 7 to break that down into smaller methods, smaller modules, smaller whatever. You should be breaking up your code at that point. I would personally argue that 7 is pretty high. I wouldn't want methods more than like 3. Just off the top of my head, just a rough guess number. Once it gets that high, I want to start breaking it down into smaller methods. Because once it gets to 7 or goodness 9, it's just too much. Writing tests to accurately test all those branches is just a lot. Yeah, Tensai, that's one of the... I don't want to talk about teaching too much. I can after... in 3 minutes after lecture. But yeah, there are some students where it doesn't matter what I do, they're just not going to pass. They're just not going to bother. Sometimes I'll have students resign in week 2, which I don't understand. But it seems like each semester of 116, I'll have someone resign in week 2. Not drop, but right after the add drop deadline. Instead of dropping the class, they wait till right after the add drop and then resign. There's nothing I can do for that student. What can I do? Yeah, probably forgot to drop, and yeah, but that shows up on my stats, is what I'm saying. They probably just forgot to drop and then resign, but that shows up in my failure rate. We have the DFRW rate. If you get a D and F, resign or withdraw. That's one of the metrics that I'm judged on, I guess. I don't know. It's something that we talk about a lot. But drops don't show up on that. So if they forget to drop and then resign, it actually counts against me. It's frustrating. So, you know what? I only got a few minutes. We can... Actually, this is one I wanted to talk about a lot. How much did I... Yeah, I do want to talk about this one. So this is a situation where that your bosses will be in out there in the real world. Like in a class, we don't have this issue in a class. If I have a class of 180 students and you all do fantastic and you all deserve A's, I could just give you all A's. Out there in the real world, the real situation is going to be more like this. An manager or an executive has 11 employees and they can only promote 3. They only have the funding for 3, or they can only promote 3 because there's 3 manager positions. There's 3 new projects that you're starting. Each one needs a manager, and you still need the other 8 employees on the ground level actually writing software and producing code. So you can't just promote everybody to manager or senior dev. Like, somebody has to fill in the slots, the positions at each level. So who do you promote? And if you're meeting with your manager and making the case that you should be one of the 3 to be promoted, how do you make that case? What metrics do you bring to that table? Or do you just go anecdotal and say, 'cause I'm awesome? What do you do to try to explain that you should be one of the 3 promoted? And what metrics do you use? Whatever metrics you use there might be the ones that you want to use elsewhere too. So, and there are a lot of dangers if you're on the other side of that, deciding who to promote. Well, what if they only worked on one project, and on that project the client was just being a total jerk? They were changing their mind all the time, never settling on requirements, and how do we make sure that's not held against the employee? If you're up for promotion, are you smoozing the boss? I've seen this before. Somebody just didn't work. It was at one of my internships. They didn't really work, and they didn't produce code. They didn't create pull requests. They didn't really do anything. They did very little in the whole time I was there. But they spent a lot of time just talking to people and joking with everybody and playing the social game. And they got more opportunities because of that. I kept tabs with some people, and that person did actually end up getting fired eventually because that caught up to them. Well, hey, you're not actually doing your job. And they actually did fire him eventually. But for a while, he got away with that. He was really impressing people just because, they liked hanging out with them. So being careful about those people. Are they just, trying to suck up to you to get what they want, but not actually do their job? Get rid of them. And make sure you have enough metrics to make those decisions. And if you're making the case that you should be promoted, bring enough metrics to be able to argue that. We're out of time, but I want to make sure if there's one more that I have a side story for. The rest of these, otherwise you can download the slides and take a look. I don't think there is another one that I really had a good story for. This one's good. I could talk about that, but I don't know how pertinent it is when we're 2 minutes over. But all 3 of these should reinforce each other. I feel like sometimes there's disconnects between these, especially between theoretical and practical. I see a lot. The theoretical side kind of branched and did its own thing. The practical side branched, and we should have more overlap there. But and then how should you, when you're looking at your own project, what metrics can you use for analyzing your own code? Size of each class is a good one. Average method size, method complexity, weighted methods per class. Actually, I'm not honestly positive what that one means. Weighted methods per class. Methods per class, sure. What does it mean for a method to be weighted? Average number of parameters per method. It's a good one. Some methods, I would argue some methods need a lot of parameters, but most don't. And when they use a lot, some of those should be optional. Number of subclasses, your inheritance tree. I've seen how I've even written code with really deep inheritance trees that didn't need to be as deep as they were. And it just adds a lot of complexity. Number of overridden operations, number of added operations and subclasses, and specialization index. I don't know what that one is either. Sorry. So a lot of things you can look at your own code and see if your metrics are out of whack on these, and you're struggling to modify the code base. The two might be correlated, though I can't show any causation. All right. So that's the end of the lecture. Let's hang out and chat. Who is the best programmer in the class? The professor. Am I part of the class? That's one nice thing about software engineering is that's not always true. I've seen students who might be better programmers than me. Most of my job is to focus on education these days, so I don't take it as a hit to ego. But there are students who, they go to all the hackathons and they're constantly writing code and they're sharp, they're on top of their game. They might be better programmers than me. It happens. But if you ask them to design a course, that's what I do. I'm going to be better at that than them. And writing code, even for software engineers, writing code is only one part of your job. I hope you're learning that. I hope that's apparent in this course. Writing code is one of the few things that you're assessed on. That's one of the very few things that's important in software engineering. Obviously, you have to be able to produce software, but it's kind of like saying an author, if you're writing novels or something, that an author needs to be able to use proper sentence structure. Like, yeah, they do, but that's like such a small part of their job. They also have to be able to put together a compelling story and write character arcs and convince publishers that their work is worthy of being published. And there's a lot more that goes into it than just sentence structure. Same thing with software developers. Yes, you have to be able to produce code, but it's just a small part of your overall job. There's so much more to it, to being a software engineer. If you can write great code, but you can't design it all, you're not going to go very far. I've had someone tell me before. I was working on them with a team. I was managing the team, and they just weren't performing very well. And we were talking one day, and the person actually got frustrated with me. It's like, look, if you just tell me exactly what you want me to write, I can write that for you. I'm like, that's not how this works. Like, I need you to be able to design. Here's the problem that I need you to solve. If I were to break this into tiny little bite-sized tasks for you, I would probably just do it myself, because that's 80% of the work. That's if you're just expecting your job and your employer to just give you, here's these bite-sized tasks, kind of like homework assignments, like you're used to getting in college. You're just not going to be able to provide that much value to your employer, because that means they have to have somebody chop up everything into tasks for you. Really what organizations need, what companies need, is somebody where, hey, I have this problem, fix it with software, and you should be able to take it from there. Take the things that you learned from this class, break that into user stories, or if you have a bad taste of user stories in your mouth after this class and you want to capture your requirements in some other way, go for it. But capture your requirements, write them up, organize, architect your software, write with testability in mind, actually write your tests, and take all those things seriously. Now you're talking. And guess what? When it's 3 of 11 are getting promoted, you're going to be one of those 3 if you can do all that. Well, if you're the only software engineer to work for that company, you're never getting promoted. That's if that was part of the promotion conversation. If you're the only software engineer, you're never getting promoted. Because if they promote you to, I mean, then you might get promoted from like a title change, junior dev to senior dev, but you can't get promoted into like a manager position or anything else because they're going to need a software engineer. The only way they can promote you is if they hire another software engineer. So that's a bad spot to be in because the company needs you in that current position. They can't promote you. Only title change promotions. Which, hey, if you're happy writing software, which actually is a big thing in the software industry, is that a lot of software engineers enjoy writing software. So when it comes to that promotion decision, especially when it's a developer to a manager position, some people won't take that promotion because they don't get to write software anymore once they get promoted into a managerial position. So if you're one of those, which is, I believe, the majority of software engineers, then that's no big deal. A lot of software engineers aren't even looking for promotions. To be honest, I mean, in this industry, you make so much money anyway, even at an entry-level position. There's no financial incentive for promotions, so it's, or little to none, I should say. Some people are, always want more money, but there's very little financial incentive to get promoted. So it's more of a question of what do you want to do. Most people don't want to do, budget decisions and calling meetings and tracking metrics and things like that. Most people who went into the software engineering field anyway don't want to do all that management stuff. They'd rather just be creating software. So if you do want to go into a manager position in software engineering and you are competent, you might have that opportunity. It might be a lot easier than you think. You have to do your time, of course. You have to, so you understand what's happening at the ground level. But once you put in 5 years maybe, just guessing that number, but once you put in your time, the manager position should be available to you. Yeah, but you also write the least code. That's going to backfire on you. This I read. Yeah, I think that. Did you say that? Is that a reword? Whew. Yeah, so this is another one we can do, and this is one that I use. I looked at how students are doing in 220 and 250, and likewise how the former 115 students are doing in my 116. The problem is, and that's good for anecdotal evidence, but we can't use that as hard evidence, because if Chun Ming said, Jesse, if your students do better in 220 and 250, then I'm going to give you more money. Then I'm going to go to the 220 and 250 instructors and say, hey, I noticed you've been failing a lot of my students. Could you really not do that? And if I were really, I probably wouldn't actually do that because I'm not that malicious. I'd just be like, well, it looks like I ain't getting that bonus. But if I were really malicious, I would go to them and say, hey, I'll split this bonus with you if you lower your bar for passing. And that's where the problems can come in. I wouldn't do that, but I would be incentivized to do that. And that's what, going back to what I was saying earlier, when somebody makes a decision, especially if I don't agree with it, I look at what they're incentivized to do. And usually it's the way everything is structured, they're incentivized to make the decision that they made. And I usually don't hold that against people personally. If they made a decision that I wouldn't have made, but they were incentivized to do that, I'm going to look to whoever put in the structure in place to incentivize them to do that. And a lot of times there's no person to blame. It's just the whole system, the way all the actors interacted with each other. Nobody's acting in bad faith, but it generates a system that appears like they're acting in bad faith, which, I don't know, there's a lot to it. I like thinking about that stuff. It's fascinating to me to just see how everything interacts with each other. and what makes people make the decisions that they make. It's really fun stuff to look at. Yeah. Oh yeah, and I read this. Some students will just perform poorly. It doesn't. So this is why. So I really ramped up my day one speech in 116, and I make sure that they know that at a minimum they need to spend 12 hours a week on the course, and if they don't, they're probably gonna fail. And then they all laugh at me. They don't take it seriously, and then they don't put in the hours, and then the students who don't put in the hours, they fail, and I just don't know what I can do about that either. A lot of my focus of course design is trying to motivate students to keep working. I try to make assignments that aren't these cookie cutter vanilla computer science questions. Like instead of saying, what's an example for my assignments this year? Like instead of just having them write when I'm doing OOP, actually that's before OOP, when I'm doing classes and objects for the first time, instead of just saying write a class that does XYZ and instantiate it and then do this and get this task done, instead of having some very vanilla one, one of my assignments is to have them write a physics engine that creates these physics vector class and then works with these objects of type physics vector and passes them by reference and does all these things. And then the rest of the assignment, the part that I give them, is a game that uses that physics engine. So they have the full game there, but there's no physics engine. Their job is to write the physics engine, and then all of a sudden, as they're working on it, the game starts working, and they're actually able to move around in the game world and detect collisions and all the like. So like that takes a long time to make that assignment, but I think it's better to motivate students. I think it does more to motivate students than if I just said, write a class with these methods and just do it, just get it done so we can do it. Or write an animal abstract class and then extend it in this dog class, and when the dog speaks it should say woof, and then make a cat class that extends animal, and when it makes a sound it should say meow. Like that's super boring, I think. So I try to make more interesting stuff, but beyond that I don't know what else to do. Trying to motivate them, and then if they're just not willing to put in the hours and nothing I do is able to excite them and motivate them to put in the hours, I'm just kind of out of ideas with that. And I still have ideas, I still have things that I'm trying, but nothing really seems to be sticking. Or maybe it is, and my failure rates would be a lot higher if I wasn't doing those things. But there's only so much I can do without watering down the courses, and I'm not willing to do that, because at that point I'm providing less value than you're paying for. Like you're paying your tuition, the checks are clear, and you're paying tens of thousands of dollars throughout your 4 years here. I'm gonna deliver what you're paying for, and I don't know. I don't like being blamed when students don't like accepting what they're paying for, because it's hard work. Like, yeah, it is, but I don't know. You wouldn't go to like a karate sensei and say, "Teach me karate. Here's a bunch of money," and then get mad when they ask you to do a bunch of reps of punching or something. Hey, you need to work out too. No, I don't want to do that. Why did I give you all that money? Do you need something? You gotta wait, babe. I'll be downstairs in, I don't know, sometime. Yeah, wait, sweetie. Yeah, and looking. So one thing we would like to do is track them after they graduate. After students graduate, track their success and try to have some measure of success after graduation. Problem with that is alumni don't answer their emails. We get once they graduate, they're just gone. A very small fraction of them will respond, and those are usually the students who are great students and are doing well. We can't get data on like the below 3.0 students. They weren't even responsive when they were here for 4 years. They're certainly not responsive after they graduate. So we just don't have way of collecting that data, unfortunately, because those are exactly the students we need data on are exactly the ones who won't give us data. And a metric of grades is a problem. Yeah, probably. If the metric is grades, I can always just give better grades. The difference between passing and failing is a big difference, because especially in like a 116, it's passing, okay, that's my stamp of approval, you're ready for 220, 250. Failing means, no, you're not ready for the next step, you need to spend some more time with me here. But beyond that, like, if I'm judged on the average grade of a class, I'm just going to turn C's into B's and B's into A's, because they don't matter all that much. Either way, they're going to the next semester. But grades are one of the things that I can use to motivate students, which makes it nice, because that's what most students, the only thing they seem to care about. So I can come up with a grading structure that if you want to get a better grade, you have to learn more stuff, which is nice, because I can use that to motivate them to actually learn. That's one thing that does seem to work. But once I have students who are content with an F, I don't have that motivation for them anymore. Once they're like, whatever, I'll get an F. It's no big deal. Whatever, I'll just resign. It's really hard to reach those students. And I notice, one trend I'm starting to notice more is some students will overload their schedule with the intent of dropping their hardest class. So if 116 is their hardest class, they're going to drop it. And again, I don't see what I can really do about that. That's more for non-majors. I mean, if your 116 is required for your degree, you're going to take it anyway. But that's another thing. Like, if I'm the hardest class they're taking that semester, they're just going to drop. They're going to resign, and there's nothing I can do about it. And that's held against me. Like, do I have to just not be, like, am I in a race with other professors to not be the hardest class? Because that's just incentivizing all of us to make our courses more easy. I don't know, it's tough. It's a tough question, which is fun because it keeps me interested. If these were all easy questions to answer, I probably wouldn't be here, because I'd be bored out of my mind. Yeah, they're messing with my batting average, man. Trying to get my numbers down. It's so hard. It's hard to get the numbers better, but also still deliver the content. Like, I know I talk about 116 a lot because it's, it's an important course that I teach. That second semester is a pretty critical foundation laying course. But now I forgot my point, because I wanted to say that. Oh yeah, but I can't, like, there's a certain amount of material that I have to cover, and there's a certain amount of understanding that I have to force the students to know before they go on. Like, when I covered linked lists and trees, the structures in those, and they just don't understand it, I can't just pass them, because they're going to fail 250. They have no chance. If they can't even understand that a linked list node has a value and a reference to the next node in the linked list, if they can't follow that, or more likely they're not willing to follow that and not willing to put into work to even watch lectures, I can't pass them, because they will fail 250. And if we pass them in 250 without understanding that as well, then we've just failed them in delivering value for their tuition dollars. So besides just watering down the courses, I don't have a good answer yet. And it might just be that some students won't put in the work. And maybe that's just the answer, which is pretty much where it's at. Just the ones who aren't willing to work, they just got to fail. I don't like doing it. I wish it were different. I wish I could pass 90% or more of the class, but if they're not willing to work with me, in struggling through life, that is what happens a lot. Is they hit that one assignment that's really tough and they don't finish it, and it just demotivates them. So this is one angle of attack I can take. I've been trying this, but I can go further, but I don't know the exact action item there, because I can't really make, if I make the assignment easier, so somehow I have to make the assignment still test what I need it to test, but be easier. And like, what do I do there? So some of it's in playing with like but I can't make it too. What am I trying to say here? Like, I could do something like give them more feedback in Autolab that explains exactly what they did wrong. And I'll do that in like 115. Sometimes I'll give them more feedback and say, look, I have these tests. You failed these ones. You passed these ones, etc. But I can't keep doing that. In 116, maybe I can do a little more than I do right now. But by the time they get to 442, if every class along the way gave them tons of feedback in Autolab, and then all of a sudden they have to just write software without any feedback at all, then they have to do their own testing, I don't think we would be preparing them for that. And that's one thing I might try next semester, giving them more feedback, but I have to be careful about how much I give, because I used to give a lot. In some offerings at 115, I gave tons of feedback each time they submitted, and you just get students guessing, checking. They'll submit, they'll get the feedback, they'll update based on that feedback without thinking about it, then submit again, get their new feedback, and just keep going one step at a time like that. And especially when I told them, like, I'd give them a whole bunch of objectives that they have to complete, and I would tell them which ones they completed. So then they're just working on that one objective, but they miss the whole point of what they're doing. They don't understand how to write software, how to write code at that point, because I just give them so much of a crutch that they aren't actually writing code. They're just manipulating my feedback and just using that as a guess and check method. So that's a tough one. But so how do I do that? So how do I avoid this? That's the big question. More feedback could help. Partial credit can help, but then students, I've done that plenty of times, but then they get to the point where they get enough points and then they just stop working. So that's tough. So where do I draw the line of enough points according to my grading structure? Well, I'll let them get this many points easily, and then if they work harder, they get, it's a huge balancing act at that point. It becomes tough. Yeah. Slander Jesse by failing my classes. Is that by messing up the batting average? Yeah, this is from the struggling through life twice. I was gonna say, two of you are saying this. It's more, but yeah, that is something to look at. At the same time, I can't have the first homework be too easy, because when I look at the data, when I do all my analysis, so every student who fails, at the very least, the ones who were close to passing, the 10 or 20 that were closest to passing, every semester I'll always look at everything they did throughout the semester and try to figure out why they failed, and specifically, is there something I could have done to help them? And every single semester, it's because they just didn't do most of the stuff, like not even showing up to labs and things like that. So I want the first homework to be difficult enough to make sure students understand that I'm serious, that they need to put in 12 hours a week. But I want it to be easy enough to avoid what you're talking about, to have them get discouraged right off the bat and then stop working because of that. And that's a difficult balance to make. Right now in 116, I have homework 1. There's no homework 0, and homework 1 is an option of 2 assignments. And one is easier than the other one, pretty clearly, and the class knows that. So they kind of get that choice. But I don't like that either, because too many of the slackers take the easy one, and then they don't understand how hard the course is after that. I don't know. It's a tough thing. I spent a lot of time thinking about course design. And I can certainly get better. There's something. There's going to be something that, makes a good dent in the problem. Yeah, but that's a good angle to put, avoiding that discouragement instead of, because I try to encourage, I should look more at the trying not to discourage side of things as well. I've also, for this reason, gotten very generous with homework extensions. As long as they've tried to complete the assignment before the deadline, I give them like a 1 month extension after that, where they can keep working. As long as they show me they were trying, as long as they put in some effort before the deadline. So hopefully that helped, but it's not making a big dent in my numbers, my failure rates. Yeah, Frosty dude, you might be in good shape there. Make it through those first few years, get some experience, and then get in the manager spot. It's very possible in this industry. Yeah, salary negotiations too. When you're negotiating that, you're asking for a raise. Yeah, what metrics do you come in with? Yeah, or just have charisma 100. That's what that one story I said. That dude had quite a bit of charisma, but once they realized that he wasn't producing anything, that's when that person gets the can. Get out of here. Do your job properly first, and then smooth. That's not the worst. I mean, I don't like that plan, but it's not the worst plan if your goal is to move up, climb the ladder. But do your job at least decent. You don't have to be the best, but at least do your job decent. Don't be on your boss's shit list. And after that, it's all about the extracurriculars. But somebody who's doing a fantastic job, writes the most beautiful code, but like doesn't show up to social events, they might not get that promotion. They might get looked over just because they're not in people's faces telling everybody how great they are.